Welcome to the Explainer. Today we're going to do something really special. We're transforming the official Grade 3 science curriculum into an exciting, step-by-step roadmap of a young learner's scientific journey. Just imagine stepping into a classroom where, instead of just being handed a heavy textbook, you're handed a mission. Because honestly, that's exactly what this curriculum is designed to do.
Now, we didn't just pull this roadmap out of thin air. It comes straight from the official Department of Education and Bagong Pilipinas framework, specifically their 3-term budget of work. So every single step, every experiment, and every observation we're going to look at aligns perfectly with national standards. It is a beautifully structured plan for building real, foundational scientific literacy. So we're breaking the academic year down into 4 distinct acts today. We'll start with Term 1, equipping the explorer, move on to Term 2, the local expedition, then Term 3, looking up and out, and we'll wrap the whole thing up with their real-world performance tasks.
All right, let's jump right into Term 1, equipping the explorer.
Think of this first term as base camp. Before these kids can go out and conquer the world, they've got to master their scientific toolkit, right? This is where the action actually starts. Through guided activities, students aren't just passively reading. They're learning to tinker. They're asking, what if? They really drill down into crucial process skills like observing the world around them, making predictions about what might happen next, and measuring with actual precision. And they're not just guessing here. They're getting hands-on with millimeters, centimeters, and meters, picking up the universal language of scientific measurement.
It's honestly fascinating how early they introduce real-world responsibility, too. The kids learn about the physical properties of solid materials. Is it stretchable? Is it hard? Is it shiny? But here's the kicker. There's a direct comparison drawn between safe material handling and harmful practices. They are actively taught that reusing objects and recycling paper is the way to go, while burning trash or just dumping excess oil into the garbage actually harms living and non-living things in our environment.
So, how does this actually look in the classroom? Well, instead of just sitting at a desk, students embark on these active, guided missions. They cycle through science tool stations, practicing with hand lenses to spot tiny details, and using modeling clay to see exactly how materials change when you shape or press them. They even go on an exploration of metals in their own community to discover the everyday uses of things like iron, gold, silver, and copper. It's all about making the science completely tangible. Moving right along to Term 2, the local expedition.
Now that they're fully equipped with their foundational skills, our explorers confidently step out into their immediate environment. The big focus in Term 2 is learning how to categorize the world. Students learn to clearly distinguish between living and non-living things. They learn that living things share very specific traits. They grow, they respond to their environment, and they reproduce. Plus, they discover exactly what plants and animals absolutely need to survive, which boils down to air, food, water, and shelter. Kind of makes you realize we all share the exact same basic needs, doesn't it?
But the expedition doesn't stop at living things. They also dive into the physical world of motion. They start asking, hey, how do things actually move? They get to experiment with natural causes of motion, like watching the wind rustle some leaves, or water carrying a stick down a stream. And they compare that to human actions, like actively pushing, pulling, or rolling an object themselves.
And the way they lock these concepts in is just brilliant. Imagine going on a schoolyard sorting walk where students wander around the school, classifying literally everything they see as living or non-living on a chart. They observe seed growth over a few days to watch life happen in real time, and they set up moving object stations to test how an object's size, shape, heaviness, and surface texture affect how it rolls or slides. It is pure, joyful physics in action.
But that brings us to a kind of fascinating pivot in the curriculum. Once these young learners have totally mastered the tangible, easily observable world, the plants, the animals, the moving objects, we have to ask a big question. How do students investigate the intangible? How do you measure what you can't easily hold in your hand?
Which perfectly sets up Term 3, looking up and out. In this final stretch of the year, the explorer's perspective drastically widens to invisible forces and the vast sky above them. Students explore how sound transfers in everyday situations, like a ringing bell. They observe how light behaves and track down its sources. They also get to play meteorologist, observing and recording weather patterns over a consecutive 5 to 7 days. And then they look up. They carefully observe natural celestial bodies, the sun, the moon, planets, and stars, and track how they appear to move across the sky.
And what I absolutely love about this part of the curriculum is the practicality.
It connects these massive scientific concepts straight to personal safety. It's not just about memorizing that the sun is a star, it's about recognizing the harmful effects of its heat and light. Students actively learn how to protect themselves from harsh sunlight, like staying in the shade or wearing a hat, and they discuss how severe weather patterns pose very real threats to their health and safety.
To really cement this knowledge, their guided missions get incredibly dynamic. We're talking literal scavenger hunts around the school to find natural and artificial sources of light and sound. They have deep discussions about how different weather impacts daily activities, like farming or traveling. They even create their own safety reminder cards for their outdoor routines, applying their brand new scientific knowledge to protect themselves and their friends.
And finally, that brings us to our last stop, real-world performance tasks.
Because across all 3 terms, the ultimate goal isn't just rote memorization for some multiple-choice test, right? It's proving their knowledge by actually doing something with it. Just look at this progression. In Term 1, they're tasked with designing and creating a useful everyday product, like a vase, entirely out of recyclable materials. In Term 2, they synthesize all that biology knowledge by creating a model or a collage of a living thing in its basic needs. And by Term 3, they literally become little engineers. They have to design, build, and demonstrate a working device capable of sending a message to a classmate 5 meters away using only light or sound energy. Absolutely incredible.
Looking back at this whole year-long roadmap, it really challenges how we view early education. When you see an 8-year-old building a communication device out of recycled materials or tracking weather patterns to keep their community safe, it leaves us with one vital thought. Are we just teaching students to memorize facts, or are we actively equipping the next generation of environmentally responsible, real-world scientific explorers? Thanks so much for joining me on this explainer, and I hope it leaves you just as inspired by the future of science education as I am.